sales manager with.
Gets us
I'll do
every
it again.
time. Go
Hello,
ahead.
everyone. I'm Brian Kuntz, sales manager with Weather-Rite. Thanks for joining today. We're excited to be talking with you all about some industrial and commercial grade applications and how our air handlers serve various markets, various applications. I'll hand it over to James Raddick, who will walk you through some conceptual, application-driven principles and other information, and then we'll also cover some offerings as well. So really excited to be here today. Before we get too deep into it, I'm going to hand it over to Jamie and Dan to introduce themselves. So Jamie, feel free to take it away.
Hey, thanks again for the opportunity. Really appreciate the chance to, speak at slash with you folks. And just give you a little quick background on myself. I've been in the industry for 40 years, started out as a electrician, wiring and test firing equipment, worked my way up through different things, service, troubleshooting, applications, sales, etc. I'm a licensed contractor, the HVAC contractor in the state of Michigan, and I'm really excited to be able to share some of these concepts with you because I'm betting that many of you haven't heard them, and you're going to go, oh, "Wow, I never thought of it that way." So this is a fun day today for me. So with that, I will turn it over to Mr. Daniel Dobek.
Hi, my name is Dan, or I go by Dan. Been with the company for 11 years. Also went to college, got myself a mechanical engineering degree. Sometimes I get some of my applications, got to think outside the box to create something unique to help meet customers' demands. So, like,
Perfect.
you know,
Thank you both. So with that, just to give you guys a quick history, Weather-Rite is a brand of specified air solutions. As specified, we operate and manufacture out of Grand Rapids, Michigan. If you were part of, I believe it was last month's webinar, we also manufacture Phoenix Air Systems out of the same facility. So we have a lot of commonality from a manufacturing standpoint that a lot of the principles kind of carry over from brand to brand. Really enables us to really be effective in the various markets. We are also part of the Madison Air family, which is one of the world's largest privately held companies. And our mission under the Madison family is quite simple. It's to make this world a healthier, safer, and more productive environment. And with our air handlers, we're certainly going to be talking about how we accomplish that mission and the various applications that we operate in. So what you can see here in the picture shown is a large distribution center. It's actually about 1.3 million square foot. We have 16 air handlers on this particular facility, providing adequate air throughout the entirety of this building. So that's, whoops, moving ahead of myself already. So that's really, in a nutshell, what we try and drive is that indoor air quality. We want to make sure it's, it's within OSHA standards. It's, it's healthy for the environment. It's keeping workers comfortable. And sometimes even helping the productivity within the facility and the throughput, whatever the product is. So at Weather-Rite, we offer energy efficient, direct fired makeup air units that provide heating, cooling, energy recovery, certainly pressurization and ventilation. Our air handlers improve indoor air quality and comfort by establishing that slightly pressurized condition while also gently tempering outdoor air and or mixed air with existing indoor air. So Jamie's definitely going to talk a little bit more about that in depth in a few slides here. So here you can see a few different configurations of our units, but hitting on that building pressurization, that is probably the number one most important concept that we're going to talk about here today. And Jamie will give you some better detail and examples of that. But if you have a negatively pressurized space, you're certainly going to be pulling in contaminants. You're not going to have the healthiest of environment for your workers or your products, and it could certainly cause some issues. So that's probably the biggest thing. Obviously, there's a lot more that goes into that with heating, cooling, ventilation, air exchange rates, things of that nature. But that's definitely a big one. So Jamie and Dan already mentioned it, but we here at Weather-Rite have a ton of experience on the team, over 200 years of industry experience from engineering, design, application, and our service and parts team. So it's, we have all the experience, we've seen it, we've done it. So it really helps us with all these new projects that come across on our plate. just a few of the markets that we typically serve in. I mentioned anything industrial, which is a wide umbrella, but more specifically, anything with heavy welding environments, anything really dealing with manufacturing and fabrication, steel storage, distribution centers, boat manufacturing, aircraft hangars you can see pictured in the middle row here, canning applications, injection molding applications, bus or garage depots, and then in the bottom right corner, waste and water treatment facilities. So as you can see, it's a wide range of applications, and each one has kind of its own unique feature, that we can incorporate into our semi-custom units. I say semi-custom, but it's probably a step below full custom. We have various offerings and features that can accommodate, different missions through all the different applications that we see. Just a few satisfied customers that we've recently done projects with. Textron, falls in the aircraft hangar realm. Kohler Heavy Manufacturing in Wilson Trailer Company, which deals with just a ton of welding, and I'm going to show on the next slide here that you might be familiar with. So this one is, in fact, at a Wilson facility. You can see in the before picture at the top, just a heavy cloud. Really, it's from the weld fumes for the most part, but also, I believe they had some slightly negative pressure in this space, which really caused them more issues than they even anticipated because they were able to expel or exhaust out any makeup air that was coming into the facility. So it was just kind of lingering in the facility, creating the foggy conditions. And a different angle, but in the after picture, you can see that fog is just completely alleviated, through the proper air change and tampering of the air that were provided in our makeup air units. So again, talking about throughput, but this certainly ties into worker comfort as well. So with that, I'm going to hand it over to Jamie to dive a little bit deeper into a few of the concepts that are involved with our equipment.
Hey, thanks again, Brian. Yeah, positive pressure. If you go back to that other slide, just one up there, Brian, to emphasize again, that's the big difference you'll see between a negatively, a building that's got excessive exhaust, et cetera. They don't have positive pressurization within the facility. And the second, the nice crystal clear. I have personally been involved, for decades producing these kinds of results for people. So I know these concepts that I'm going to present today work. And it's very exciting and gratifying when you're able to go in and solve a customer's, air quality issue. And along with air quality goes comfort, et cetera. So we'll go on to the, as Brian had said, positive building pressure. And just to understand how powerful that can be, it's, air is a fluid. It always moves from areas of high pressure to surrounding areas of low pressure. This is just a little isobar, weather graphic showing air moving from high to low. It always does that. It's just the nature of physics, et cetera. So let's think about how we can corral that and incorporate that into how we start working on buildings. So Brian, the next slide, please. Okay. Again, air is a fluid. It always moves from high areas of high pressure to surrounding low pressure areas. I've unfortunately personally been involved with too many tires that went flat because the pressure came out. I've never seen a tire inflate itself. So let's see. I think what we'll do is, Tracy, we were going to hold the questions towards the end, right?
That's correct. Yeah.
Okay. All right. Yep. So please, yes, let's hold the questions and we'll address them all at the end because a lot of the questions you'll be, maybe we'll get answered as we're going through here. But I definitely appreciate the interest. So again, I've been involved with tires that deflated, never reinflated. And another example of pressure going from high to low is a simple bucket that you've got high pressure water, low pressure on the holes coming out of it. That's just the way it always flows. So keeping that in mind, we'll go on to some of the next stuff. Okay. And, that pressurized, vessel, that tire I showed was a vessel. That pail was a vessel. It's a vessel, simply a container that's holding something and it's holding pressure. So if we think about a building as something that can contain pressure, it's going to have equal pressure throughout. It doesn't matter where that valve stem is on your tire. When you go and measure it, it's reading the same, pressure within it, and it can be measured anywhere in there. If you had multiple valve stems, it'd be the same pressure everywhere. So keep that in mind as we're talking about this for the pressurization concept. And Brian, okay, how much pressure? And we're only talking about a hundredths of an inch water column. That is so minute that the second bullet point there talks about 400 feet per minute. Well, what's that equate to? That's what you would have if you have a building that's pressurized to a hundredths of an inch water column. And that's what we found that level to be ideal in the fact that it gives us the benefits that I'm going to talk about for positive pressurization without high cost of pushing unnecessary amounts of air out of the building, and heating more air than what's needed. That 400 feet per minute, if you were the gentleman standing there in the doorway and your building was pressurized to 100ths of an inch water column, you would stand there and on a winter day, you would not feel air going past you. 400 feet per minute is very, very hard to perceive. It's very slow moving. So what you would stand in that door and perceive is not warm air rushing past you, but cold air is not entering the building, which you typically see with any other type of heating system, whatever, that's not pressurized. Okay. Now, people ask, well, what about a gust? You can't tell me that you're going to be a whole back of gusts. No, but what I'd like you to think about regarding gusts are kind of like, think of the slow moving, air moving out of any opening in the building going out. A wind gust is just a higher energy that comes in, but it's like a fish that's swimming upstream. After that initial burst, if that fish doesn't keep swimming upstream, it's gently moved downstream right back where it came from. And that's what happens with wind gusts. I've been in so many buildings that have a negative pressure in it. A cold gust comes in and it'll shoot into the building, 100 or more feet into it, making everybody in that area very uncomfortable. If you've ever been in buildings in the wintertime and saw ice by the dock doors that was coming in on the floor, that's because the building was negative and that cold air is just coming in and keeps rushing under the door. So again, low pressure, hundredths of an inch water column, we found that's just enough pressure to, turn and stop infiltration. We're not really pushing any more air out than what would be coming in through the building leaking anyways. So that's a misperception that some people have that, oh, you're blowing all that air out. No, we're simply taking it and pre-tempering it with our equipment and moving it towards those doors. So we stop that cold air infiltration where it is. And you gain a lot of benefits with it, which we'll go about next here, Brian, please. Okay. Truly, exhaust sucks, literally. Okay. That image there, I've got a arrow pointing at an exhaust fan that was put. This is a building where they were trying to manage dirt. This is an area where there's a process going on. They're crushing products, or they're crushing waste product, packaging, etc. And they put an exhaust fan there. That exhaust fan is running and it's moving a decent amount of air, probably 10 to 15,000 CFM of air there. And the reason I'm saying exhaust only captures air with certainty that the air that comes within one diameter of the opening. Okay. I'm going to show you the American Council of Industrial Hygienists, a lot smarter folks than I am. They've got it defined there, and they've got some great graphics I'm going to share with you in a moment. But what I want to really stress here is you've got the negative there on the building. You've got an exhaust fan running, and the stuff that's circled on the floor is that dirt and whatnot that's being produced. The exhaust fan is that close to it. If it can't capture dirt, dirt and contaminants that are that close to it, it doesn't, general exhaust doesn't have a prayer of picking up any contaminants that are, like I said, that are outside of one diameter of the fan. So the next screen is that taken from the Government Hygienist's Handbook. exhaust fans can only capture at most air within an area within equal to about one diameter of the fan. And what you got in that graphic, that presentation is on the left, it's an image of a exhaust, duct, if you will, that's going into the build, that's protruding into a space. And you can see on that plane, 0 diameter, half 0.5 diameter, 1 diameter. Look at how quickly the velocity that's relating to velocity as you get away from it, how quickly that degrades down to 7.5%. You can be 1 diameter away from it and hardly feel that air moving. If you're trying to capture dirt and nasties that are in the air, it's simply not going to happen effectively. Now you see the other one, the image to the right is just showing an exhaust fan, typical of a wall-mounted exhaust fan. Once you get beyond that 1 diameter away, that air is moving so slowly that just about anything, any activity, as I said in the bottom bullet point there, without positive pressure, just about any activity is going to severely impact the effectiveness of an exhaust fan. The big difference then is that now, okay, so how do we improve that? How do we improve that? And that is, of course, going to be with positive pressurization. Brian? Okay. Before I jump past that, though, I want to talk about the second bullet point there. Increasing amounts of exhaust. Everyone thinks, oh, I'm not quite getting the air quality I'm looking for. I must need more exhaust. And we've unfortunately probably all been in buildings that have a very, very, very high level of, negative pressure within it. And, can make the doors dangerous to be around for opening and closing, etc. And again, due to its mass, air is going to take the path of least resistance to reach an area of low pressure, which means it's going to short circuit, which is illustrated in my next slide. Right there we go. This is a little bit stepped away picture of that same facility. You see there's a bunch of yellow pillars, around there guarding that electrical panel. On the other side of the electrical panel is that door with the exhaust fan in it. What's going to happen in the middle of winter when it's cold outside, you got a wind blowing in against the building, or even just the negative pressure that's created within it when you don't have the proper makeup air for exhaust. And now I'm not anti-exhaust. But I don't believe exhaust is prudent when you don't have a correct amount of makeup air to replace it, and actually enough makeup air to slightly positively pressurize it and start moving everything towards those points where you're trying to get rid of it. And what would happen if you're the poor person that's going out into this trash compactor, or by that other open door that's partially open to a shredding piece of equipment, and you're in that area? The air is going to take the path least resistance, and it's going to be very cold, and you're going to have winter misery in those areas. And that's why you end up with uncomfortable, around the perimeter of the building that's not positively pressurized. That cold air comes in, and it's difficult to get it to mix. So this next is just an image of that same facility that Brian was talking about. And in that corner that's highlighted red, you can see we've got a dark arrow showing the exhaust blowing out. And within that area, the red arrows are illustrating the migration of dirt away from there. Now, how could that dirt move away from there? Well, I've got a general negative, but I also have outside influences. Buildings are dynamic. If people are making money, you've got a dynamic building. There's things going on, production, doors opening, closing, etc. What happens when that wind blows? Those green arrows are showing wind blowing on a building like that. What that does is create flows within the building that just distribute that dirt and nasties everywhere. I was in this building, and you had severe transfer of dirt, etc., away from that door for literally 100, 150, up to 200 feet away from it, and beyond that. So again, the way we're going to combat that is what we're going to show in the next some coming up here. Brian? Okay. And you're probably all familiar with these. Just drop that in there. Signs of building needs makeup air. There's a lot of them out there. There's poor air quality. You just can't get rid of the nasties that are inside the building because of the things we talk about. backdrafting, you've seen, hard opening doors, etc., uneven temperatures. How bad does it get? The worse negative a building gets, the more uncomfortable it gets, the more you're going to have a hot core in the middle of the building trying to keep the perimeter miserable, or you're going to have to use some other types of, radiant heat to try and put a band-aid on what really needs to be a positive pressurized space. High energy bills, it's unbalanced heating and cooling. Cold air comes in, it displaces warm air near the, hot air near the floor that your heating system is producing and pushes it up to the ceiling, doing anybody good, it just costing money to heat that air. Excessive grease, this is for kitchens. Everyone's familiar with that. Exhaust fans not working properly. The harder and harder, the more exhaust you put on a room, the more negative it gets. It's like a Coke bottle if you got multiple straws in a Coke bottle, pulling on that and you don't have way for air to come in, it just keeps getting worse and worse. And actually the performance overall on every one of the exhaust fans are competing for air goes down. And of course, I talked about the negative pressure. So with that, pressurization does something else for us. Okay, it allows us to monitor processes and door activity. We want to keep the bucket full, if you will. That when we're trying to achieve a positive pressure in the space, and I'm going to go more into the benefits here momentarily, it allows us the green arrows are just illustrating a positively pressurized vessel or a building that has equal pressure throughout. And the orange rectangle is illustrating an air handler. Now, if you've got something pressurized, it doesn't matter how far is that door that opens, or that exhaust process that could be illustrated by the short arrow that's pointing upwards on there. Is it that close to the air handler? Great. One would think, well, okay, it's easy enough to monitor that, but what about that exhaust process, the other arrows that's showing way, way down? It doesn't matter how far away it is. It allows you to use the building as sometimes think of it as, a pneumatic. Pneumatics were the rage for many, many years about controlling dampers, controlling, many, many things. Well, just think of the building under that slight positive pressure as being pneumatically interlocked. If a door opens quite far away from the air handler, your overall pressure in your space is going to drop. And the units themselves are equipped with an indoor and an outdoor pressure sensor, reading that differential and striving to maintain. It'll modulate its dampers for outside air and return air to bring it the right mix to provide that, hundredths of an inch water column pressure. So going on to the next, low discharge temperature. We want to think about the fact you could look at just about anybody and say, hey, heat rises, right? Well, there's a great example of heat rising right there in the picture, right? No, that's a great example of hot air rising. Why does hot air rise? Because it's so much less dense than the surrounding airstream around it. I'd like to go to the next screen and show that heat is energy, and it doesn't know up, down, right, or left. It just knows it's radiating, it's faster moving molecules rubbing on its neighbors, transferring that energy and making their molecules, move faster, and so on and so forth, to infinity, if you will. So heat transfer, you want to think about the fact that, you have conduction. That's basically what that illustration is showing, is conduction through a mass. And we don't take into account and give enough credit to the fact that air has mass. Okay. We have to think about that. It's like, okay, well, I'm sitting in an area that the heating vent or air conditioning vent is, 15 feet away from me. I'm not directly in that airflow, and yet I've got an even temperature throughout the space. If it's not because of airflow moving, it's because of the thermodynamics transferring energy through the air and conducting it through that mass. And again, hot air is great for sightseeing, but bad for buildings. When you discharge hot air into a facility, that's when you start seeing stratification in the building. In fact, if we go to the next slide, stratification wastes energy, it's uncomfortable, and 99% of the time it's created by the building heating system. Okay, that is a powerful thing to get our hands around. Typical heating systems that discharge air, high temperature air into the space, unit heaters, et cetera, whatever it is, they can be expected, and this is well documented, that they can experience approximately 1 degree Fahrenheit rise for each foot in height as you get away from the floor. So that's illustration on the left does a great job of showing that if this is a 30-foot space and you've got 65 desired temperature for people at the floors, you could very easily get 95 degrees at the roof level. That's not doing anybody any good. It's just costing money. So it truly is a waste. Now, how do you combat stratification? It's a lot easier to deal with by just simply not creating it in the first place. Stratification's mortal enemy is low supply air temperature of about 30 degrees above the desired space temperature. And that's what the Weather-Rite products controls that we have. We will strive to maintain positive pressure because it then gives us control over all of the air in the facility instead of cold air coming in and laying along the floor and pushing heated air to the ceiling. We maintain that slight positive. It makes everybody more comfortable around the space. It gives you even temperatures throughout the space. Can you go back to that a second, Brian? And then we can also ensure that we don't have that stratification issue because our control system not only monitors that positive pressure and reacts to it with either varying the amount of outside air, return air mix, but it also then monitors the space temperature. And we have parameters in there that even if your space was, let's say on a morning warm up, your space would cool down on a weekend below 60 degrees and you wanted 65. The worst thing you can do is throw high temperature air in it. Get that heat into the space, get that heat. No, what that'll happen is you're going to get that high levels of stratification occurring. So with the next slide here, Brian, please. Again, we want to keep in mind air as mass. It conducts heat in all directions, up, down, left, right, forever thereafter. So the key to preventing stratification is introducing tempered air. This is very key, within 30 degrees of the space temperature. And then after that, thermodynamics distributes heat over an unlimited distance. Okay, let's go down to the next slide, Brian. Okay, so with that 30 degrees, I know, and again, I'm very passionate about this because I've seen it work for the last 40 years. It's a great concept. Positively pressurize a space, use a low discharge temperature. What happens to that space, that discharge temperature? If it was 65 and it's more than, let's say, 1.5 to 2 degrees below it, if your space set point was 65 and the actual was more than 1.5 to 2 degrees below it, our system would recognize that and the dampers would be off doing their thing to maintain the positive pressure. The heating control system would say, okay, well, great. It's chilly in here. I want to bring the temperature up as quickly as possible, but we cap it at 30 degrees. And this is actually right into our algorithm on our controls. There's a way to override it if necessary, and you felt you needed higher temperature than that. But we find that people inadvertently, whether it's service people, end users, et cetera, if you give them the option to set their discharge temperature, they'll think, oh, hotter's better. If they don't understand this, and it's so hard, you never know who's coming in to replace a retiring worker, et cetera. If they don't understand that hotter is not better, they can go in and adjust that temperature to a higher temperature, to a maximum like 110, 120, and now you're creating stratification. I know that happens because I've gone into a few different buildings and seen where our system was in place and they were seeing some stratification. Took a tour of the building and found out that some well-meaning contractor had raised the supply air maximum temperature up to about 120 degrees, which is about the max on this equipment, 110, 120. And so you can imagine the customer's surprise when, after doing a tour of the facility and turning the discharge temperature maximum set point down, and they came out of their office and they said, wow, what'd you do to it? The stratification's really, That's really better now. Wow, it's gone. What did you do? You can imagine there are puzzled looks you get when you say, well, I turned the maximum discharge temperature down. That's why this is so, it's a unique concept. You know, it's been around a long time, but people just don't understand it. So we actually have our air controls designed so that they will adjust. If somebody sets it to 60 degrees for a desired space temperature, it'll automatically cap the maximum temperature going out 30 degrees above that. So that way people can't inadvertently cause themselves harm, you know, in building performance. So again, those two systems, they allow you to put a building on cruise control. And by cruise control, the reason I reference that is, where does your car get the best mileage? It's out on the highway. On the highway, what happens? You got different constantly varying loads, whether you're going uphill, downhill, headwind, tailwind, etc. Cruise control locks it in. It doesn't spend any more energy than it has to maintain that temperature. And that's really what you want your system to do, building, air management system. And I like to stress the words air management because that's what positive pressure allows you to do. Your air management system you want to set up so it acts the same way. Doors open, doors closed. Bring in more outside air, bring in less outside air. As heat loss in the building increases or decreases, the system actually modulates it. Now, how does it do that though? Okay. We don't cycle. Oop, Brian got ahead of me there. He's an eager guy. He's excited to share this concept with you too. Um, you don't want to activate. What we do is we activate, modulate, and turn off heat as needed for temperature control. Typically, when it comes on a winter day, it's going to start up. And what happens in the building um, when people are in it? You need ventilation. You know, huge examples of that was, during COVID, and what was the best way to improve air quality inside the building? That was to bring in more outside air and flush the nasties out. Well, by setting your ventilation rate at, and this is, you can talk to, the folks at Holden, et cetera, about helping you with the ventilation rates for different occupancy rates. We just don't simply have enough time to get into that today, but they can help you through that and figure out what you need, enough ventilation to heat the building with that low temperature, and you also need the enough building air ventilation to provide the air quality you're looking for. So again, the greater of those two is what you need, and folks at Holden are who you'd want to talk to about getting the skinny or the more of the details on that. Because again, I'm sorry, we don't have time to go into the big detail on that today. But again, you're going to activate and turn the burner and modulate the burner. Well, your car has a gas pedal, right? And cruise control, et cetera. It modulates the energy being produced by your the engine. Well, this is how we do it with an air handler. We have a modulating burner. It's a direct fired burner. Don't be concerned. There's still folks out there that are concerned over direct fired burners. They see the flame, it's in the airstream, which is great because you getting 100% of the heat produced by the flame is being delivered to the space. You can't get any more efficient than that. And it's also safe. That burner you're looking at there burns about approximately 100 times cleaner than the gas range or oven in everybody's homes. Nobody gives a thought about that, okay, when you don't want to use them for heat, et cetera. Because why? Because they don't have outside air to come in and dilute the contaminants. We are not only burning 100 times cleaner than those gas stoves and ovens in everybody's house, but we're bringing in outside air to dilute it. And OSHA standards, ANSI standards allow us to add up to 5 parts per million of carbon monoxide to the air that's coming in. In practice, it's typically around 2 or 3, no matter what the burner modulation range is. So this is very safe and very, very efficient. So highlighting again, high discharge temperatures. With that, you get cold air coming in near the floor. It pushes high temperature up because you get that oil water effect. The greater the density difference is, the more the energy, basically repels itself, et cetera. You want that hot air to rise. Discharge temperatures within 30 degrees are the ones that are going to give you even temperatures along with the positive pressurization, you can count on your space temperatures to be within a degree or two, wall to wall, floor to ceiling. And even on 100-foot buildings. Let's see that next slide there, Brian, please. Oh, you know what? Back up to one more second. I'm sorry. The proof is out there. I know of a building. It's an aircraft hangar. Brian had talked about aircraft hangars, etc. It's an aircraft hangar with 116-foot clear between the floor and where the air handlers are mounted in the rafters. They're distributing heat straight down at the floor. So if there's so if there's any facility that's got a recipe for for stratification, that would be it. But on a minus 14-degree day, they were measuring about 1 degree between the floor and the ceiling. And what we find is that if you turn off the lights and measure that temperature, that stratification level goes away completely. Many years ago, when light systems were less efficient, we would then measure 2.5, 3 degrees, and we thought our system was doing that. But then we did more study, learned as we went, and with our system, you don't create stratification. So any stratification there would be basically the byproduct of some wasted heat energy from inefficient lighting. But how incredible is that? 100-foot ceiling, large. It was a very, very big aircraft hangar. We had to hold back the stratification or the infiltration with that positive pressure combined with the low discharge temperature. And you just can't get, better performance than that, in addition to the air quality that you're bringing to the space by bringing in fresh air. In fact, I can say without a doubt, I know of no building that has a direct fired piece of equipment, that does this kind of concept that didn't have an improvement in air quality after the system was installed with direct fired. You can't say that about other types of heating systems, unfortunately. Indirect fired equipment, etc. It's not a question of if, it's a question of when, etc. So properly maintained burners here, they are really fantastic performers. All right, Brian, please. So putting it all together, positive building pressure, low discharge temperature, and gives you that cruise control. So what's next? Applications. I'm going to go through this really quickly. I don't want to lose out on some of the end. Here are some of the things that Brian wants to tell you about our equipment. But getting back to that building, warehouse with dust control problems. How did we address it? Okay, we've got this view showing the nasty area with the exhaust in the corner. Let's go to the next slide, please. We did it by looking at the exhaust that was leaving the building, infiltration error. We calculated an infiltration rate based on construction, etc. And then we try to take exhaust plus any infiltration rate, CFM, and we then take that total of air leaving the building, and as a rule of thumb, we add 10% to it. That's what I've used for literally decades, and I've never been let down. It provides you that slight positive pressure you're looking for. Of course, when the doors are closed, you at 400 feet per minute through a dock door, you don't want people leaving their doors open. It will cost them a pretty penny. But with a typical building that they're trying to conserve as much energy, but they're still looking for air quality and comfort, that hundredths of an inch water column will get them there with the air change rate. Again, it's exhaust plus estimated infiltration rate, the total of those two, add 10% to that, and that's the amount that you want to have for your overall system that's going into the building. And when you pressurize that building, now we want to introduce the air going from tight to loose and clean to dirty. The whole way to capture that nasties around that corner was to provide positive pressurization, which slowly moves the air, completely eradicating that nasty dust that was traveling all over the place. And it was very key for this facility because they had sorting equipment that used barcoding, sorting, etc., or even then the new code, QR code sorting, and their scanners could not handle the dust that was coming from that. And we solved that again through positive pressurization. We introduced the air where and moved it from clean to dirty. And so instead of it being nasty everywhere, it was better everywhere when we do that. So again, when you think about placing equipment, go tight to loose and clean to dirty. And we've got a tool out there that you know folks at Holden can share with you if they'd like to. It's basically a decision tree. It's kind of small here to see, but basically all you're doing is you're starting at the top and you say, does your building have general exhaust or process exhaust fans? Yes. Okay, we follow it to the right. Then our model choices are shown there. These are all the models that have the ability to bring in varying amounts of outside air. Is there contaminant in the air which cannot be recirculated back to the space? If it's no, there's no question. The air management. You remember I used that term earlier, air management, because it allows you to manage the amount of air and the heat going into the space. You can't have air management if you don't have that positive pressurization. So anyways, this is a tool. I don't want to spend a whole lot of time on it, but you can go through. And if you go down that left-hand column, let's say that first decision tree there says, does it have general and or process exhaust? No. Okay, let's go down. We're still looking. Now we're looking at all the options here. And is there any contaminant in the air which cannot be recirculated back to the space? No. Then you just follow on. In 90% of the time, you're going to find that you're going to want a variable volume recirculation mixed air unit is going to be the choice for the buildings, whether it's warehouses because of the dock doors opening and closing. It doesn't have to be big warehouses. We do all kinds of small buildings, etc. So please don't think of us just as a large building manufacturer. We can handle them. We do them very well because we make equipment that goes up to 150,000 CFM for one air handler. But please don't just think of us as the big buildings. I've done small buildings down to wash tunnels, two stall, oil change facilities, et cetera, with this type of equipment. So please don't pigeonhole us into thinking, we're only good for big buildings. It's any building that needs ventilation, and that happens to be every building. So we'll go to the next screen here. And again, this is just an example here. I think I should have gone to this slide when I was showing you how that decision tree works, just easier to see. This is the bread and butter, this AM model. AM stands again for air management. It uses a fan, and you can see the upper air path is going over the image there that's showing a direct fired burner. Whenever the burner's in operation, we will be supplying a minimum amount of outside air, typically 20% as needed to provide for heat and diluting the product's combustion. So we meet those ASHRAE and ANSI standards. The other 80% of that fan capacity can be made up of either return air or outside air. You can see the link between those dampers. Any mixture thereof, what your building needs. Okay, so that's an example of an air management unit and how it accomplishes what you're looking at. And basically, air rotation, air turnover, that's a decent concept. What we've done is taken it a step further. Okay, by pressurized air rotation, you're moving a lot of air. That allows you to get to the low discharge temperatures that you would see. But it doesn't do anything for that positive pressurization, making up that air that a building needs to manage it. This system, if you think about it, is a modulating makeup air married to an air rotation unit. You're getting the best of both worlds with this type of a unit. Now we manufacture, and Brian's going to touch base on this a little bit more in just a couple slide or two. That industrial equipment, that top one you're looking there, it welded construction, et cetera. It's got a lot of great things going for it. I personally had an experience where somebody sent me a picture of the inside of an electrical panel that was on a unit that was built nearly 40 years ago. And guess whose initials were on the quality control sticker? I saw my own sticker. So I know this stuff lasts. Okay, these industrial units, you know, they're more expensive, sure, but they're very often worth that extended, that extended life. Now, the extended lifespan for commercial equipment, which we manufacture too, 15 to 20 years. And if you go into the next slide here, industrial grade, I like to say it's more than worth the premium. What you're looking at is a cutaway of the inside of that air management style air handler. I've got one arrow pointing to the fan shaft. For that, I wanted to show the bearings because we use bearings in this equipment that are no less than L10 of 100,000 hours. And many of the horizontal equipment, it's approaching more like 350 to 400 1,000 hours of life expected for less than 10% of the product to expect a failure. The center arrow is pointing to the inside that we manufacture. We take a fan cone and a fan wheel that's purchased from a supplier, and we build our own housing around it. So that allows us to optimize the amount of CFM that we can put through a given cabinet size. It allows us to make sure that it's built strong and robust. And then that third arrow all the way over to the right showing the type of, on our industrial equipment, the type of airfoil fan we use. It's an airfoil fan wheel. Airfoils are quiet. They're most efficient. Those two things go together. If you're spinning a wheel and you're not moving air, you're making noise. So it stands to reason. The more efficient, it's going to be quieter. So these are great. Don't think of these as, the kind of air, the volume, the audible volume that you would get from them as being, like most typical forward curve fans or prop fan units. These are very, very quiet. They're invariably the quietest product out there. And that insulation inside is added not so much for thermal efficiency. The payback on that is very, very far extended. But if you have an application where you need something to be very, very quiet, go with this style fan. And by insulating the inside of our cabinet, we basically cut the the noise level about in half. The decibels go down 2 to 3 decibels. And highlighting here again, can your customer not to afford not to upgrade? You've got forward curve, backward incline. The backward incline is going to give you every day, every minute, electrical savings on your operating horsepower. So I think that wraps up mine. Okay, yep. Brian's going to take over that. I just want to say thanks again and look forward to hopefully working with you all in the future.
Thank you, Jamie. Appreciate that. So keeping all the concepts and principles that Jamie just walked you through, just to cover a high level overview of our offerings with Weather-Rite. Jamie mentioned we go from 0 upwards to 150,000 CFM. So I'll talk about some unit configurations, but all of the different features and controls are within that 0 to 150,000 CFM range. Again, focusing on that building pressurization, makeup, fresh air supply, and temperature conditioning and control that Jamie was talking about. Again, fully welded, 16 gauge wall casing. We offer it in single and double wall, insulated, non-insulated. Backward inclined airfoil fan, like Jamie just covered, offers that highest efficiency available and the quietest operation available. Direct fired only. For now, we are looking at in the future bringing back indirect fired offerings. That'll probably be a conversation for next year. Of course, I'll let Holden know, and they can advertise that as needed. Maybe we can have another training session when that product gets launched. But really, the other big piece is the customized design. We can, from trying to match footprints to unique controlling that Jamie was talking about within this facility. It's really kind of a Lego set of whatever you need an air handler to do for your facility. We also offer cooling upwards to 65,000 CFM. That's about the cap for that. And then we can also offer electric, hot water, steam as it relates to alternate heat sources. We offer energy recovery, and we also offer filtration upwards to the HEPA filters. DDC controls are standard. We do have some other offerings, from a control standpoint as well that I'll touch on more here in a few slides. So just a few breakdown on what that fully welded construction looks like. The goal there is to handle the harshest environments, right? All these components that go into these units are corrosion resistant, aluminized steel housing. What's shown and what we advertise as our industrial series units are called the TT series, which is shown here. So really just hyper focused around the long lasting durability and quality grade air handling unit to accommodate for a long lifespan. So on the flip side, we have our commercial, or what we call light industrial grade direct fired makeup air units. So this is more of that bolt fastener screw together design, so not fully welded, single wall insulated, non-insulated, no double wall with this XT series, and this series goes upwards to 40,000 CFM. So also direct fired. Again, the whole indirect fired conversation would apply to this as well. We'll talk about that next year, and then similar controls and design capabilities. So you heard Jamie mention a few times on air management. Those are also called 80/20 units. 20% outdoor air, 80% return air. You can also see the variable air volume models, fixed recirc models, of course, 100% outside air model. Those are the four kind of groupings that we operate with. As far as configurations go, it's pretty much anything and everything. We're pretty adaptable, given a unique situation. You can see here from just indoor mezzanine supported, or indoor suspended over to your typical outdoor horizontal roof curb, or horizontal maybe on the ground level or indoor with legs. And then of course you have your upright orientations as well. So just touching a little bit more on the control side of things, ultimately this is the brain of our units, right? So we want to make sure that it's firing in the sequence of operation. It is doing the job that's needed within a particular facility. So we want to make sure it's easy to use and easy to service. That's huge for all the contractors that work on our pieces of equipment. To offer that, we also want to offer the greater control around temperature, humidity, building pressure. We have a variety of sensors that will allow our unit to turn on and off when needed, depending on whatever the set point is for that facility. You can have early detection of problems. So there's alarms that are also offerings for our control package. And then data collection and trending also helps with some building management systems that you can plug, inputs and outputs into. And then just the overall compatibility. I've not really ran across an issue where we've had any issues connecting with other existing building automation systems. So, with that, that really comes from our wide offerings from a control package standpoint. So, what's all said and done, we want to make sure that our end user is being as profitable as possible by preventing employee turnover, by providing that clean, fresh air, and flushing the room to provide a more healthier environment, which can also help with throughput in some cases. And just making sure that you can flush that space and rid it of any contaminants. And you can also offer some free cooling at night, more in our economizer mode. But there's definitely certain features that can offer more cost savings to the end user. Predictability, we don't just help on the upfront side of things, but our service and parts team is excellent with handling and troubleshooting, post-install situations. We can offer training, around the time of installations that really helps the end user know what they're getting. We understand it's an investment, and we want to make sure that our end users are trained on this piece of equipment. Then dependability. Just recently, we've actually reduced our lead times due to some headways we've made with procurement efforts. So our industrial TT series is sitting at 10 to 12 weeks. Our commercial light grade XT series is sitting like 6 to 8 weeks. If you add cooling, you can just add 2 weeks onto that. Those two lead times. Sorry, just for the industrial. Cooling is only offered for the industrial. Need to clarify that. And then we have the ability to manufacture 30 plus makeup air units a month. So we tackle large jobs, upwards of 60, maybe even to 100 if we had to, by staging it right. But no issues with delivery. We really want to, pride ourselves in taking care of our customers, and along with that is the contractor, the engineering firm that might be in the mix. So, it's very common for us to get on the horn and go over performances and review our submittals, in person with our customers, contractors, engineering firms. So, one other thing I wanted to call out, we do have a selection software for our products. So Holden does use that very often. So they can come to your office, they can crank out a selection with you if needed. And I'm sure they'd be happy to set that up for you. But right there and then you can get a quote, you can get high level submittal. We can offer a more in-depth submittal if needed. But you can pretty much get all of your technical information and pricing right there and then with them. So I highly encourage you all to work with Holden on any projects that you feel are needed to incorporate fresh outside air or positive pressure. So with that, I do want to leave some time. I think we got about 4 minutes for questions. I know we got at least one here. So Tracy, I can't see it yet, but I will hand it over to you and we can start going through some Q&A.